All right, so today we're going to talk about the multivariable polynomials. So this is where I typically would say that the concepts are all the same. The looks of it is different, but the concept is still the same. So what do I mean by that? Meaning that just because there's more than one variable doesn't mean that we wouldn't do the same things no matter if it is one variable versus two variables versus three variables. We're still going to do the same thing. So if we look at it, they might tell you to evaluate. So let's say, for example, they want you to evaluate x squared minus y squared plus xy. And they tell you that x is equal to 2 and y is equal to -3, let's say. Okay? So when you do this, the way I would tell you to do it is every time you're going to sub it in, make sure you use parentheses. So what I'm going to do is I'm going to say, okay, so my x is 2, so I'm going to put parentheses 2 before I square it, minus parentheses -3 before I square it. And the x, y, when the two letters are next to each other with no operation, put in the middle, operation meaning addition, subtraction, multiplication, division. If there is no operation shown, then it's always assumed to be multiplication. So this is actually 2 times -3. Okay? So as I'm doing this, I'm going to say, okay, what's 2 squared? 2 squared is 4. Minus -3 squared. So how about if I put it this way? This is actually meaning -3 times -3. Okay? So -3 times -3 is actually a 9. Right? Because the reason why I wrote the -3 twice is because the squared term, the power, is attached to the parentheses. So it's telling me to write the parentheses twice. All right? If it was only attached just to the 3, then I would write the 3 twice, but not the -3 twice. Okay? And then this is plus and -6. So now I have 4 minus 9 plus a -6. So this right here is going to give me a -5 plus a -6. So I lost money. I had $4. I lost 9. So I'm down $5. And then I lost another $6. So I got -11. Okay. So that would be one example of, but we're still doing exactly the same thing if it was just x's, right? And not x and y's. All right. So with combining like terms, it's the same idea as well. Right? So before I said, okay, so if we had a 2x to the third, right? And we said, okay, so this right here, we're going to call it red because this is called the power or the exponent. Right? And then let's call this blue, and this is called the base. And then the 2 is just the coefficient, okay? So in order for us to add or subtract them, we had to have like terms, and like terms meant the same power and the same base, okay? So now when we have more variables, meaning our base is going to increase, then it's still going to be the same idea with the base and the power still has to be the same. So let me write here, like terms, adding, subtracting polynomials, same base and same power. Okay, so let's say I'm given, let's do something simple. So example, let's say I'm given 7AU plus 6AV plus 56AU plus 6AV. Okay, so if you look at this, what you have to see is this, is that AU and, and AU are the like terms, while the AV and the other AV, let's try this again, is also like terms, okay? So again, if you have more than one base, the base has to be the same. If you have more than one power, the powers have to be the same, and it has to be the one that's attached to that base, okay? So in this case, I'm gonna have, in this case, I'm gonna have, what's 7 plus 56, 63 AU plus 12 AV. And that would be my answer, okay? So you're like, okay, what about powers, right? How about powers? Well, okay, so let's say I have an example of, that says 9x to the 8th y minus 5x y to the 9th and plus x cubed, okay? So in order for me to find a like term that looks like this, actually, you know what, that's probably a bad idea. Let's do it this way. If I want to find like terms of the 9x to the 8th y, I have to have another term that will have x to the 8th y. If I don't, then they're not like terms. And I don't have another one, right? I don't have another x to the 8th y. Okay, so if that's the case, so let's see if there's any terms that has x, y to the 9th. Nope, no other terms that are x, y to the 9th. So therefore, I can only combine the one that has x, y to the 9th. And then I can look at this one here. Is there any one that has just x cubed? And the answer is no, okay? So, and it can only be x cubed. It can't be you can't say, okay, it's an x cubed y and one just an x cubed, so I can combine, you can't. So if this says x cubed y, well, the rest of it has to be also x cubed y as well. So this has no like terms. So therefore my answer is going to be 9x to the 8th y minus 5x y to the 9th plus x cubed. Okay? But what if the example was this? 9x, let's go this way, squared y cubed minus 5 x cubed y squared plus 9 x squared y squared. Do I have any like terms there? Or heck, let's even just do it this way. Do I have any like terms there? And the answer is no, because in order for it to be like terms, I would actually have to have, all of this. Still did too much. You do two. So it'll have to be x squared and y cubed all together. It can't just be part of it, okay? So there's no like terms here, so therefore the answer is just going to be 9x squared y cubed minus 5x cubed y squared plus 9x squared. So that would be the answer. So it's a lot more difficult to find like terms than just, picking things up and go. So that's the only thing, all right? So adding, subtracting is the same. Multiplying, however, let's look at multiplying. What will happen? So let's do an example with that. So let's say I got m plus 2n squared. Well, what does this mean? The squared is attached to the parentheses, so it's telling me to write the parentheses twice. Okay, so that means I have to FOIL or double distribute. So I've got, let me do this here. That red, so I can do m times m plus 2n plus 2n times m plus 2n. So what do I have? So same idea, right? So when I distribute this, let's do it this way. This is going to give me m squared. This is going to give me positive, I got 2mn. 2 times m times n. Let me write this meter. Okay. Then when I multiply this one, I'm going to get positive 2mn. So what you want to do is kind of have a system where if I'm going to write mn, which is alphabetical order, or nm, which is not alphabetical order, either way, just stay consistent. Don't write one as mn and one as nm, okay? So these two are actually like terms, and then my last part is I got 2 times 2, which is 4. N times n is n squared, okay? So multiplying is the same idea, except we're multiplying instead. Now, when we're adding and subtracting, here are my like terms. They're both mn. So I'm going to have m squared plus 4mn plus 4n squared. So that would be my answer there. Okay? Well, I hope this helps you guys. If you have any questions, let me know.